Yes, sir. Adnan.
Assalamu alaikum, sir.
Wa alaikum salam wa rahmatullahi wa barakatuh. Adnan, we are continuing from here. Structured part. Question 8, part C. This one from this graph. So, can you read it, Adnan?
কোথা থেকে স্যার?
C, part C. 8C. We are continuing from 8C.
A sample contains a large number of radioactive nuclei that emits beta particles. The sample is placed near to a radiation detector in a laboratory, and the count rate is recorded over a long period of time. Figure 8.2 shows the count rate recorded by the detector during this period.
So, here we have one information that emit beta particles and count rate is recorded over a long period of time. That's it. There is nothing that much important to note down. So we are focusing in this diagram now, this graph, to find the answer of this question. So C1, this part is very easy for you. Suggest two major sources of background radiation. So what are the two sources of background radiation?
Radon gas, তারপর fossil fuels বলা যায়।
Fossil, cosmic gas, nuclear waste.
Yes, yes. So you know this one. Now using figure 8.2, we can find the answer of these questions. The first question is to find the background count rate.
22 count per minute.
Yeah, you got 22 count per minute. How?
I went to the curve where it's just straight line and then saw the number.
Yes, yes. So, Adnan, you understood it. How she got 22 as background count from the graph? Adnan, did you understand?
Yep.
Can you explain how, Adnan?
No.
Sir, এটা তো per minute.
Yeah, Adnan, can you explain how we got 22 counts as background?
কারণ এইটা হচ্ছে অলমোস্ট ইয়েতে এন্ড করে তাই গ্রাফের ইয়েটা দেখে।
Okay, the ending of the graphs, you see there we are getting one straight line, constant, right? And
Yep.
this constant means we are getting all the reading from the surroundings. We are getting from the source that is negligible, and the count rate we are getting only from the background sources. So that's why it is coming constant, right? Here we are getting one straight line. So if you count from 20, then we are going 21, 22. That's giving you the background count, 22 counts per minute. Is it clear? Hello?
Yes.
Yes, sir.
So if your background count is 22, you record it, huh? In your copy, you record it, and this information is required for our next calculation. You see, determine the count rate at time 0 due to the sample on its own.
Assalamu alaikum, sir.
Wa alaikum salam. So
27 count per minute.
27 counts per minute. You are getting here 27 counts. How? 27?
There is 49 written, so if we subtract the background count rate, then it's 27.
So Adnan, you understood it. Azmain, Aisha.
No, I didn't.
Yeah, look here. We are at the beginning. This count rate we are getting with background. Huh? Background plus the count from the source, altogether we are getting 49. This one, right? At time 0. So what is the count rate only for the sources? That one we are going to find. So only from the source we are getting, if you subtract 49, if you subtract the background count from 49, then you are getting your count from the source. Your background count was how much, Adnan?
49 minus 22 করলে যা আসে তা।
No, I'm asking.
27,
Your background count was how much?
22.
22.
22
Yes, so you are subtracting 22 from 49. Then you are getting 27, right?
yes
So 27 is your counted from the source, only source.
What if
And
from the background radiation?
yes, I know you will ask this question because you joined late. Look, we are having here straight line, right? Hello, Aisha.
Yes.
So this
Yeah.
one is showing that for many days, look, 600 to 700 days is almost, we are having the same count rate, right?
Yeah.
That means we are not getting any count or radiation or any emission from the source now. We are having whatever is coming from the background, right? Or the surroundings.
Okay.
So
Okay.
if you get from the graph, it's coming 20, then 21, 22. That is your background count. Can you note down it, Aisha?
Yeah.
And the next
Yeah.
one we also discussed. After background count rate, this one we discussed count rate due to the sample. That is 40. You please note down it. 47, 49 minus 22. It is 27. Okay, now estimate the half-life of the radioactive atoms in the sample. Ziba, you just hold on and please just, I know you know the answer. It's more likely that you know the answer, but I want others to get the answer by them. If they can't, now they will do. Okay, Ziba?
Okay, sir.
Hello, Ziba. So we are going to find the half-life, and Adnan, Aisha, Azmain, you will help us to get the answer. Estimate the half-life of the radioactive atoms in the sample. From the graph we can get it. How will get the half-life? Can anyone give any idea? Yeah, Adnan, how you will measure the half-life?
বললেন স্যার
Yes, how will get the half-life from this graph?
Sir, 27 divided by
With
6.
the information available with you, you have the background count rate, you have the count rate you are getting from the sample at the time 0. So using these two information, you can find the half-life from the graph. Try it, everyone. Yeah, tell me, Aisha, you wanted to say anything?
27 divided by 6.
Why 6? Why you are thinking about 6?
600.
Half-life? No, 20, 27 will be half. The count rate will be half after one half-life, right?
Yeah.
So what will be it? After one half-life, 27 will be how much? Can you say how much it is? Is it 13.5?
13.5.
Yes. So this graph is not giving you solely the count rate from the sample. It's also giving you the count rate of background. So with this 13.5, you have to add that 22. So how much is coming?
35.5.
30?
5.5.
Is it 35.5 or 33? 35.5.
35.5.
Okay, very good. Then 35.5 we are writing. Good. So 35.5, you check here where we are getting 35.5. That one is your half-life. Do you understand? This one is a bit.
Sir, can you explain it again?
Yes, sure. I will
99
explain.
days.
You see, I will explain it again because Yakin joined late. He might not understand about the background count and the sample count from the sample. Look, Yakin, we had before two more steps before discussion of this step. Look here. I am explaining. No problem. Look here, we have determined a value for the background count rate in the laboratory. How we got it? We got it from the graph. You see here we are getting a straight line for long
Yes,
period
sir.
of time 600 to 700. That means we are not getting any count now from the source. We are getting all the count from the background. So this
Yes,
one
sir.
is giving us background count 22. Note down it, huh? So your
22 from the counts per minute rate, right?
yeah, 22 counts per minute for background
Yes, sir.
sources. Okay, so that is
Okay,
background
sir.
radiation or background count. Now at the beginning, with all the, you see, for all the part of the graph we are getting the reading is with background, isn't it? It's not
Yes,
only
sir.
from the source. So at the beginning we are getting 49.
49. Yes, sir.
So at the beginning we are getting 49. So if we want to know what is the count rate from the source or sample, that is 27, right? Because 49 minus 22,
49 minus 22.
yes, it will be 27. That is only from the source. So
Yes, sir.
your half-life is related to the count rate from the source, not from the background radiation.
From the background radiation.
Not from the background radiation. It's only from the
Yes, sir.
source. So
Source.
we are making half. That one is only for sample or source, not for background.
Okay,
Is
sir.
it clear? That's why
Yes, sir.
we made it half and it's coming 13.5. Now, as this graph
Then
is,
we will add
yeah,
22 because of the background radiation.
yes, as this graph is wholly or solely for the background count included, that's why we are adding that one. It's coming 35.5. Now we'll check here 35.5 where it's coming. That is our half-life. Can you check it
Okay, sir.
all? Check it everyone, then you tell me.
99 days.
99 days. Then
80
Ziba,
days.
Ziba, what is your reading coming?
No,
80
80
80 to
days.
85 days. Like something in between, I guess.
Yes, sir. Something
85.
in between.
In
So
between
we
what?
just go with 80. We go with the nearest whole number, 80.
Okay, can we draw the graph here? Straight line here, 35.5.
Let me try.
Yeah, if you draw the graph, it will come more visible for us to make,
Sir, could you make the
understandable.
screen a bit bigger?
Sure. Is it okay now?
Yes. Where is the thing? Sir, give the minus. 80 days. Can you see it?
Mm-hmm.
That's 80 days.
80 days. So, what about others? Did you understand it? Hello?
Yes,
Yes, sir.
sir.
So, it's clear to you, right? And for
Yes, sir.
this type of graph, we are taking little bit range. If someone is writing with 82, 85, that one we also accept. Okay. Is it clear?
Yes, sir.
Okay, then we are going to next part. Half-life is done. Now we are going for last part. D. D1. Yeah, Yakin, you read D.
A student suggests a change to the experiment C, which suggests completely encasing the radiation detector in lead before the sample that emits beta particle is placed near to. The effect on the count rate of the background radiation may then be ignored. Describe and explain the effect on background count recorded by a detector of the completely encasing radiation detector in lead.
So what you will see, what you will understand from here, or what you will observe. Yeah, this one is a bit difficult question. I told you before that question number 8. It
It's
has
very
some
weird.
difficult. Yeah, you see here we have beta particles, right?
Yeah.
From the
Yes,
sample
sir.
we have beta particles, but we are keeping the detector inside lead, right? Lead
Yes.
box. So if you are giving beta particle from the source, and if you are keeping the detector inside the lead box, then will you able to get any reading from the source?
No. Yes,
No,
beta
that
particle
that
can go
idea
through lead.
that idea will use for answering question 1 and 2, D1 and 2. So you already
The
understood
student
the.
still didn't read the chapter properly. That's why he said this.
Yeah, so here we got describe and explain the effect on the background count rate recorded by the detector of completely encasing the radiation detector in lead. Now they are talking about the background count rate. You don't know which particles or radiation is coming from the background. There might be alpha, beta, gamma, all right from the background, isn't it?
Yes,
Hello.
sir.
So
Yes,
if
sir.
Yes.
alpha, beta, gamma all are coming from the background, then your shielding, the lead shielding will stop alpha and beta, but it cannot stop
Gamma
gamma,
rays.
right? Gamma, it will stop little bit, but completely it cannot stop. So what can we do, or what can we write? We can deduce that uh, the count rate will be reduced, right? Count rate will be reduced. Okay. Why count rate will be reduced?
It might stop the
because
beta
Because
particles and the alpha particles,
only some part of
Because
but
gamma
of
not
will
the.
be,
gamma rays.
yeah, only some part of gamma rays will be able to reach there, right? Or can be
yes,
detected
It
there.
will only some gamma rays. The others will just bounce off.
Yeah. Alpha and beta will be stopped over there. So can you write these 2 points, Ziba? First point and second point.
Yes, sir.
Okay. Now the other part of the question. State and explain whether the student's suggestion is a sensible one. Now you can
It is
answer it.
not.
Yeah, it's not.
It is
Why not?
not.
It's not,
It's not.
because
Why is it?
the
Because
the source is the beta particles, and beta
the
particles will be stopped
source
by
won't even go through it.
So you
So
will
the
not be
detector can't
able
even
to
detect
get
it.
any count rate from the source, right?
Yep.
yes.
You will not get any count rate on
The
the
source.
detector due to the source. So for these two reasons, we are having you can write these 2 points. You will write no. Then no is 1 point and another one is explanation. Why no? So everyone please write. Azmain and all, you please write these points. This worksheet is already given to you, Azmain. Azmain,
Yes, sir.
this worksheet you got, right?
Yes, sir.
I sent you this worksheet. So you write down all these points and you go through the worksheet. You try to understand whatever you are getting. Recording is there, but you better to write also
Okay, sir.
and analyze the questions, analyze the answers. If you have if you have any difficulties, you can ask us in class. You are a good listener. You are a good listener, mashallah. And from now on, try to also be, you know, what should I say? Speaker, good speaker. Okay, and good
Yes,
discussion.
sir.
Yeah, now we are going to
Yes, sir.
question 9.
Sir,
Should
is
we
the
go to
writing okay?
question 9? Everyone?
Yes, sir.
Okay, now we are going for question 9. Question 9. Azmain, you read. What about Moshi today?
He didn't do the first class either. Internet problems, I guess.
Okay. Yeah, Azmain, you continue. Read question 9. Hello, Azmain. Are you there? Yes, he is there. Azmain. He wrote any message? Some net problem. Azmain is writing me net problem. Okay, fine. Then Yakin, you read. Yakin, you continue.
The proton number of the element lead is 82. The isotope lead-209 is radioactive and decays by emission of beta particles. Describe the composition of and structure of neutral atom of lead-209.
So this one already you got 2 more questions, similar questions, right? It's repeated one. So can you tell
You
us
need to
the
write the answer.
composition and structure? Can you write, Ziba?
Yes, I'm writing.
This one is composition and there is structure also.
Yes, sir, writing.
Okay, then nucleons. Huh? This one should be nucleons. Nucleons stay in nucleus. Yes. So done. We can go to next part, right? They who missed class before, you did not have this idea, please take these notes.
Yes, sir.
Yeah, then next. Can you read, Yakin?
A nucleus of lead-209 emits a beta particle. states how the composition of the nucleus produced differs from the original nucleus.
Yes.
Sir,
So
the
how it is
nucleus,
different?
the
So it
The neutron reduces and a proton and electron increases.
electron increases.
Okay,
उल्टा बोलना ना.
so they are asking about the nucleus. That's why we will not tell about electrons. Only focus
Okay,
in
so
the
one proton increases.
yes, one proton increases and
One neutron decreases.
one neutron decreases. So for mentioning these 2 points, you have 2 marks.
Okay, sir.
Okay, so you write it there.
ইলেকট্রন দিলে তো মার্ক কাটবে না, জাস্ট ওইটা মানে ইরেলেভেন্ট হিসেবে ধরবে, মানে কোনো কেয়ার করবে না, তাই
Yes,
না?
yes. Mark will not be deducted, but we should focus where we have to hit. So it gain one proton and one neutron decreases. Then next, continue.
Complete the
Gamma,
table
beta,
in figure
alpha.
9.1 to show the relative ionizing effect of the 3 types of ionizing radiation produced by radioactive decay. So least strong is gamma, then in the middle is beta, and most strongly ionizing is alpha, right?
Yes, yes, yes. Correct. You are absolutely right. So you all are correct, mashallah. And Adnan was also saying at the beginning the answer. That's making me confident and happy that my learners are becoming, very much efficient, mashallah. So we are continuing 3 now. Okay, Yakin, continue.
Sir, which finger is for the magnetic field from the left hand rule?
Sir, will we use left hand
I
rule
will
or
tell
right
you.
hand rule
I
for
will
this?
tell you. We will use only left hand rule here. Okay, because here we are dealing with the motor rule. Okay,
Yes, sir.
that's why motor effect
A
is always
sample
left hand rule. Yeah, yeah.
A
Continue.
sample containing lead-209 nuclei is used to produce beam of beta particle. The beta particle enters a magnetic field. The
এরকম
magnetic
হবে না
field
স্যার।
is particular
Wait. Let him
uh,
finish reading.
particular to the direction of the travel of the beta particle. The beta particle travels from left to right. Figure 9.2 shows that the direction of the where is the rest?
Okay. Direction shows the direction of the
Shows the direction
এরকম
of
হবে কি
the
স্যার?
beam of particle
yes,
magnetic field out of the page.
yes. So
On figure
here
9.2, sketch the path.
Yeah, scale the path of the beta particles in the magnetic field. So it's clear to you, right? What you have to do. The direction is correct. Your direction is correct, and you should focus here that you have 2 marks here. Huh?
লাইন স্ট্রেট হওয়া যাবে না।
Yeah, it should not be straight. It will start carving from here, from the beginning. When it enters to the magnetic field, it should start carving. Then you will getting second mark. First mark is only for showing the direction upwards, and second mark is for showing the bending from the beginning. Okay, now you asked me one important question at the beginning. Which rule we should use, left hand rule or right hand rule?
Left
I
hand.
told you that it's motor rule we should use. That's why we should use left hand rule. That one I'm explaining why I said motor rule. Motor works
Sir, which
with,
finger is for the magnetic field?
yeah, not for that. In also right hand rule there is magnetic field, but motor rule works because we are passing
আমি রাইট হ্যান্ড লেফট
electricity.
হ্যান্ড রুল একটাও পারি না।
I am explaining you. Now you will understand. Left hand rule we use for motor, and motor works from electricity. We are getting kinetic energy. In right hand rule, we are having electricity from kinetic energy. So your beta particles is moving here. That means we are having current here, isn't it? Hello.
Yes, sir.
So as beta particles, you know, it is electron, negatively charged. So when it is moving, this charge is moving, we are having the concept of current, flow of electrons. So that's why we are getting flow of
So the
electrons.
conventional direction of current is opposite of direction of electron, right?
Right. So that one we are using also, that our beta particle is going to this direction, so our current direction will be opposite. And if you are doing that magnetic field out of the page, if you are keeping your 3 fingers, set your 3 fingers, the first finger or the index finger is towards you, right? The index finger
Yes,
is
sir.
towards you, then your second finger or the middle finger is working left side of you, right?
Yes,
Then
sir.
you will see your thumb is working upwards. So
Upwards.
thumb is working upwards. That's why the beta particle will move upwards. Is it clear now?
Yes, sir.
All of you? Azmain, Aisha, are you clear? If you are not
Yes,
clear,
sir.
you can tell me. Then I
No.
can explain. So this one is done. Now we will
ক্লাস
continue.
কয়টায় শেষ? 10:30 না?
10:25
10
10:25 এ শেষ।
10:25 is over. We are done with our class today. Now,
ওকে, আল্লাহ
1
হাফেজ
minute.
স্যার।
Can you give me 1 minute? Then say Allah Hafiz. Adnan, this part, see, we will discuss in our next class. On Monday we have class, right?
Yes.
Yes, sir.
So
Yep.
Monday we have 2 lessons. First lesson we will finish this part, and second lesson we will test on structured part. On structured part.
টেস্ট
Yes.
Radioactive and
Can you
structured.
take test a little bit later? We need to revise.
আজকে স্যার
On Monday.
টিউসডেতে নেন,
You are getting
টিউসডেতে নেন।
Tuesday te?
হ্যাঁ,
Yes, sir.
Okay, fine.
Because we
No
need
On
time to
Tuesday.
revise, sir.
Okay, no problem. No problem. Thank you. Thank you.
Thank you, sir.
ওকে, আল্লাহ হাফেজ
Allah
স্যার।
Hafiz.
Allah
Allah
Hafiz,
Hafiz,
sir.
sir.
Bye bye.
Thank you.
Assalamu alaikum.
Okay.